So in this video, we'll be learning how to set up word problems that we can then use systems of equations to solve. So for each of the 4 word problems that we're going to talk about, we're just going to set them up, and then you can use a system of equation solving strategy of your choice to actually finish them out and solve the problem. So here, this first one says that you bought 6 gallons of juice from the store. Some of these gallons were apple juice and some of them were orange juice. The apple juice cost $3 per gallon and the orange juice cost $4 per gallon. And you spent a total of $20. How many gallons of each did you buy? So when we're going to approach a word problem, the first thing we have to do is define our variables. And we're going to have variables for everything that we're ultimately trying to find. So typically we're going to use this final statement here to help us figure out what our variables are. And this question states, how many gallons of each did you buy? Now there are 2 different types of juices, and we want to know how many gallons of each we bought. So what we're going to do is we're going to select a variable for each of them. Now you could use variables like A and O for apples and orange juice. However, I often find the variable O to be difficult to use. So for this part, I'm just going to use X and Y, and I can choose a variable to represent either one. It doesn't matter. I just need to be consistent throughout this entire problem. So here I'm going to pick X to be the number of gallons of apple. And I'm then going to pick Y to be the number of gallons of orange. And again, it doesn't matter which one is X or Y, it just matters that you're consistent as you write equations for and solve the rest of this word problem, which is why I define them right at the very beginning. So now that we know what we are trying to ultimately find, if we're going to solve a system and we have 2 variables, if we have 2 variables that we need to find, we know that we're going to need 2 different equations because we have 2 unknowns. So however many unknowns you have is how many equations you need to write. So here I'm going to start by writing the first equation. And what I noticed as I read through this example is I noticed there's a bunch of cost calculating going on. So apple juice costs $3 per gallon and orange juice costs $4 per gallon, and we spent a total of $20. All of those cost calculating items tell me that there is a cost calculation equation that is being used here. So we can actually write an equation that will represent the cost in this situation. So if I think about going to a store, I know that when I go to the store, I take the price of an item and how many I buy and multiply them together to figure out their cost. So for example, I know that apple juice costs $3 per gallon. So if I write 3x, that's 3 times x, it's $3 times the number of gallons of apple juice that I have. That's what 3x represents. I also know that if I write 4y, that's $4 per gallon times the number of gallons of orange juice I have, because that is what y represents. Then I know from here, if I add them together, that that is my total cost. So I can write a cost calculating equation here, and I know that in total I spent $20. So this cost calculation right here, this 3x plus 4y, that's calculating the total cost that I spent in the store, that needs to be equal to $20 because that is how much money I spent at the store. So there I have my first equation. Then from here, the only other pieces of information that I see that I could write an equation with are how many gallons of juice I bought. So here I can see that I bought 6 total gallons of juice. And it might seem like we don't have an equation here, but we actually do. We know that we bought 6 gallons of juice. And we know that X is the number of gallons of apple and Y is the number of gallons of orange juice. So we can take X, my number of gallons of apple, plus Y, my number of gallons of orange juice, and set that equal to 6. So here I have 2 equations with 2 unknowns, and now I could use any of my solving strategies, graphing, substitution, or elimination, to solve for X and Y, and ultimately I would be able to then find how many gallons of each I bought that were a total of $20, but also resulted in me buying exactly 6 gallons from the store. So let's take a look at setting up another word problem here. So this one says a business has 2 locations and buys 7 larger delivery vans and 5 small delivery vans. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. Location B receives 2 large vans and 3 small vans for a total of $160,000. And then it says, what is the cost for each van? So when I take a look at this, my first thought is I need to find variables to represent my unknown values. And here it says, what is the cost for each van? So my 2 unknowns are the cost of a large and a small van. So that's what I'm going to set x and y equal to. I'm going to set x equal to the cost of a large van. And I'm going to set y equal to the cost of a small van, because those are ultimately the 2 things that I need to find by the end of this problem. So from here now I need to write 2 equations because I have 2 unknown variable values. And what I notice is that there's 2 cost equations here. There's one that I underlined in red for location A, and there's one that I underlined in blue for location B. So what we're going to do is we're going to write one equation for each situation. So I'm going to start with location A. And because I can see they have 5 large vans and 2 small vans, I'm going to take 5 and I'm going to set it to be multiplied by the cost of a large van. So notice I have 5x, that's 5 large vans times the cost of each large van. And then if I do the same thing with y, I have 2y, which is 2 small vans, times the cost of a small van, and I add them together. And I know in this situation that when I have 5 large vans and 2 small vans, they equal a total of $235,000. Then from here, I can follow that same process and write an equation for location B, or the second situation. So here I have 2 large vans, so I have 2x, 2 large vans times the cost of a large van. And then I have 3 small vans times the cost of a small van, and I add them together. And I know that those have a total of $160,000. So now I have 2 equations paired with my 2 unknown variable values, and now from here I can use graphing, substitution, or elimination, whichever one I think would be the most helpful, and I can solve this system of equations, and by the end, once I find values of x and y, I will then know the cost of a large van and the cost of a small van that will produce these 2 cost situations. So let's take a look at our third example. This says that the volleyball team is selling candy bars and bags of popcorn at the tournament this weekend. The volleyball team sells twice as many candy bars as bags of popcorn. They sold candy bars for $2 each and bags of popcorn for $3 each, and sold a total of $175 worth of food. Then the final question is, how many of each food item did they sell? So I know that I need to first find my variables for the items that I need to find by the end of this problem. And by the end of this problem, I need to know how many of each food item they sold. And at this particular, concession stand, they are selling candy bars and bags of popcorn. So I'm going to set x equal to the number of candy bars that are sold. And then I'm going to set y equal to the number of bags of popcorn that they sold, because those are the 2 things that by the end of this problem I need to know. They are my 2 unknowns. Now, because I have 2 unknowns, I know that I need to write 2 equations for this particular situation. And when I read through the word problem in front of me, what I immediately notice is the part that I underlined in blue is a cost calculating equation. We have candy bars for $2 each, bags of popcorn for $3 each, and there's $175 worth of food that are sold. So my first equation that I'm going to write here is going to be $2 times the number of candy bars that I sold, which I can see is represented by x. So $2 times the number of candy bars that were sold. I then know I have $3 times the number of bags of popcorn that I sold, which is represented by y. And then I add them together, and I sold a total of $175. So that's my first equation because I can see how that cost is calculated in this situation. Now, the second equation here is a bit trickier, and that pairs with what I said here in red. So it says the volleyball team sells twice as many candy bars as bags of popcorn. So when we write this equation, we really need to think it through. It says we sell twice as many candy bars. So what we need to remember here is that there are more candy bars sold. And so what I like to do is I like to think through how candy bars is going to be calculated if there are twice as many of them as bags of popcorn. So I like to write in English and say, okay, my number of candy bars, how that's going to be calculated is I'm going to take the number of bags of popcorn that I sold, and I'm going to make that twice as much, or I'm going to multiply it by 2. So I need to, whenever I know what popcorn is, take popcorn, multiply it by 2, and that will equal the amount of candy bars because I sold twice as many candy bars. Now, while I don't know those values off the top of my head right now, what I do know is there are variable values that represent these values. So I can take my variable values and replace them in for the English for what they represent. So we have candy bars here. Well, candy bars is represented by the x variable. So I have x is equal to 2 times the number of popcorn that I sold, which was represented by y. So my equation here is really candy bars, x is equal to 2 times the popcorn, which is y. So I can now erase my English in here, or you can leave it in your work, that's perfectly fine. And I now can see that I have 2 equations for this situation. Now at this point, you could use substitution, elimination, or graphing. It doesn't matter which. You use whatever strategy you think best fits the situation. And if you solve this system for these variable values, you will eventually come up with an answer for x and for y that give you the combination of candy bars and popcorn that will result in $175 sold, but then also result in there being twice as many candy bars as bags of popcorn. So let's read through and set up this final example together. Many businesses pay website hosting companies to store and maintain files that make up their website. Company A charges a setup fee of $10 and then $21.95 per month after that. Company B charges a setup fee of $0 but has a monthly fee of $22.44. Find when the 2 companies will cost the same. So when I look at this problem, what I notice is there are 2 things that we don't know. And it's kind of hidden in that final sentence there. It says find when. Well, the when is something that we don't know. We want to know when these 2 companies will have the same cost. Well, there's a bunch of items in here that talk about month and month. And so my x here, what I don't know is when these are going to be the same, but I know there's some sort of monthly fee. So for x, I'm going to call x the number of months that have gone by, because that's something I don't know, but that's kind of how time is being defined in this problem. Now, the second thing I don't know is when the costs are the same. So we have cost that can be represented by y. Now, in this problem, it kind of does matter which variable represents months and cost. So one side note that I want you to make about variables in word problems, and variables in word problems, what they represent really doesn't matter unless you're dealing with time or money. And if you have time and money in the problem, it typically does matter what you select for x and y because that's how it's commonly defined with independent versus dependent variables, or if you do a lab or something like that. So if you see anything that looks like it represents time, anything that represents time is typically your x variable. So you can see that we have number of months that represents time, and as a result, that time needs to be my x variable, which we did in this case. In addition, if you have one single cost as a variable in your word problem, so if there's 2 costs, this doesn't apply, but if there's only one variable that represents cost, that is typically represented by the y value in your situation. So kind of keep that in mind. These are common in how we define variables, especially when time and cost are both involved in the same problem. Now, we need to write an equation for each situation here. We can see how company A charges their fees and how company B charges their fees. So I am going to write an equation for company A and then come back and write an equation for company B. So if I look at company A, what I notice about company A is that their cost is calculated by charging a $10 fee and then $21.95 per month. So their cost, which is Y, is calculated by taking a one-time $10 fee plus then $21.95 per month, which we can represent by $21.95 x. Notice 21.95 times x, that's $21.95 per month being multiplied out, and then a $10 one-time setup fee that they have to pay up front. Now, if we take a look at company B, we're going to apply that same thinking. So we have y is equal to, there's a $0 setup fee, but then it is $22.45 per month. So we'll do $22.45 x. So we have $22.45 per month, and then we add on that $0 fee. Now, if this bothers you that we have 0, you could also just write y equals 22.45x because the 0 really doesn't need to be there. So now if you used graphing, substitution, or elimination, and you solved for x and y, you would be able to find at how many months these two costs are the same and what the cost will be at that many months for each company.